Good morning, Year 6. Today in Maths, we're going to start our new topic of algebra. Before we get started on algebra, we need to make sure we understand our foundation knowledge of finding and following rules in sequences. I'm going to share my screen with you now, and we're going to have a look through some work that I've prepared for you in order to understand this. In this lesson, you are going to need a piece of paper. Lined paper is fine, but squared paper would be even better if you do have some at home, but obviously lined paper is absolutely okay. You're going to need your pencil and a ruler. You may also want, but you do not need, a coloured pen for marking your own work and a printout of the questions pre-prepared. Again, you do not need these items, but they might help you if you would like them. The first thing that I'd like you to do is write down the date and WALT on your piece of paper. Okay. Throughout this lesson, where you see the pause button on the bottom right-hand side of the screen, I'd like you to pause the video in order to follow the instructions that I'm giving you. So the first thing you're going to do is press pause now, write the date and WALT, and have a go at solving the do now questions. Once you have finished writing the date, the WALT, and the do now questions, unpause your video and we can go through the questions together. Okay, hopefully you've had a chance to finish your do now questions, so we're going to have a look at them together. With this one, we're looking for equivalent fractions. I know that I need to start with the full fraction and I need to start with my numerator where I have both numbers. To get from 2 to 1, I'm dividing by 2. 4 divided by 2 is equal to 2. This fraction was equivalent to 1/2. Here, I'm looking at my denominator because I have both the denominators, so to get from 2 to 20, I must times by 10. 1 multiplied by 10 is equal to 10. On the second row here, I need to see how I get from 8 to 4. To get from 8 to 4, I must divide by 2. 10 divided by 2 is equal to 5. Here I'm looking at the denominator. Getting from 10 to 20, I must times by 2. 8 times 16 in here. My computer doesn't seem to like that. I'll move on to the next one. For this one, I need to start all the way down here because I do not have two complete fractions. So I need to start on the numerator of 12 getting to 3. In order to get from 12 to 3, I'm actually dividing by 4. So 16 divided by 4 is equal to 4. And here then, I've got my denominators, I know both of them. To get from 4 to 12, I must times by 3. 3 multiplied by 3 is equal to 9. Moving on to the next question then, it's a thinking of a number question. I always do these in the same way because it really helps me. As soon as I see the phrase thinking of a number or thinks of a number, I write down my question mark. This represents the number that Erin is thinking of. Erin thinks of a number. She multiplies this by 3 and then she adds 4. Her answer is equal to 22. Now, you might not recognise this at this point, but this can be solved using algebra. But for now, what I'm going to do is show you how to solve it using the inverse. I've written out my formula. Erin thinks of a number, she times it by 3 and adds 4. The answer is 22. To work backwards to that number, I'm going to go back through my equation doing the inverse. 22 subtract 4, because the opposite of add 4, or the inverse of add 4 is subtract 4. And then instead of timesing by 3, I will do the inverse, which is dividing by 3. 22 subtract 4 is equal to 18. Divide that by 3 and you will have 6. Erin was thinking of the number 6. Let's quickly test that out then. 6 times 3 is 18. Add 4 is 22. Her answer was 22, so that's correct. Well done if you got all of those do now questions correct. We're going to move on to the next slide now. On your piece of paper, we're going to not be able to use whiteboards in these maths lessons, and you're not going to be able to show me your work. So I think it'd be a good idea. There'll be opportunities for you to have a go at the questions throughout this lesson. It'd be a good idea for you to write down your answers on the paper and you can mark it as you go through. So on your piece of paper, underneath where you've written your do now, I suggest writing a little subtitle called input to help me know that this is your input and not your independent work. Underneath this subtitle, you can work out any jottings or answers as we are going through the lesson. The first example we're going to look at, you'll see, has a red box around the outside. When you can see the, that means it's an example that I'm going to be showing you. And when you see a green box, which we'll see on the next one, it's one where you're going to pause the video and have a go for yourself. This one has the red box, so you're going to first watch me solve this question here. My question says, what is the rule in this sequence? I can see my simple sequence of 10, 20, 30, 40. I need to first then identify, has my sequence increased or decreased? To get from 10 to 20, it is increasing. And how much has it increased by each time? I've added 10 there. Once I've found that I've added 10 to get from 10 to 20, I need to double check that rule works for the rest of my sequence. 20 add 10 is 30 and 30 add 10 equals 40. So if I'm going from left to right, I'm adding 10 each time. That means if I were doing the inverse and I was working backwards, instead of adding 10, I would have to do the opposite, which is subtract 10. I'd like you now to pause the video and have a go at solving this sequence by yourself. The question says, what is the rule in this sequence? From left to right, what's happening each time? Pause the video and have a go. So I look for two numbers next to each other and I need to decide if my sequence is increasing or decreasing each time. I can see here my sequence is increasing, so I'm going to say I'm adding. I now work out what I've added from 15 to get to 22. I'll add 5 to get to 20 and then another 2. That's adding 7 in total. I'll double check that rule works for the rest of the numbers in the sequence then. 22 add 7 is equal to 29. Add another 7, that's equal to 36. Well done if you said your rule was to add 7 each time. And remember, if your rule is to add 7 each time, the inverse, working backwards, you will do the opposite, which is subtract 7. Let's have a look at this next sequence then. I've told you that you should first start off by seeing what you're adding to your sequence or subtracting to your sequence. So 6 add 6 is equal to 12. I've then told you that you need to double check and make sure that rule works for each of the numbers in the sequence. 12 add 6 is equal to 18. The next number in my sequence was 24, but if I add 6, it will be 18. That means this sequence is not correct. So I need to go back and I need to work out how else I could have got from 6 to 12. My number is increasing, which means I've either added or multiplied. I can't add 6 each time and follow this sequence. This means I must be multiplying. What do I multiply 6 by in order to make 12? 6 times 2 is equal to 12. Now I need to check if that rule follows for the rest of the sequence. 12 times 2 is equal to 24, 24 times 2 is equal to 48, and 48 times 2 is equal to 96. So the rule for this sequence was to multiply by 2. Can I ask you please to pause the video and have a go at this sequence? Remember to double check if you're adding or multiplying. Okay, so to get from 4 to 12, I would either add 8 or I have to multiply by 3. I know that to get from 12 to 36, I cannot do that by adding 8. That tells me I must have been multiplying by 3 each time. 4 times 3 is 12, 12 times 3 is 36, and 36 times 3 is 108. The question here actually said, what is the next number in this sequence? So well done if you spotted that the question was slightly different. In order to find the next number, I would have to do 108 multiplied by 3. If you haven't done that yet, quickly pause the video and work out what 108 multiplied by 3 is. I'm going to use the short multiplication method to help me with 108 multiplied by 3. 3 times 8 is equal to 24. 3 times 0 is equal to 0, add 2 will equal 20, and 3 times 100 will equal to 300. Therefore, the next number in this sequence will be 324. At this point, you've got two choices. You can either pause the video and solve the first 4 questions independently on your piece of paper, or you can keep on watching and answer all of the questions at the end. So you can pause the video now and try the first 4 questions and then watch the rest of the video, or you can keep on watching the video and solve all of the questions at the end. We're now going to look at something called a function machine. A function machine can be presented in lots of different ways, but these ones will look roughly like this each time. You can see on the left-hand side, I've got the input. In the middle is the function, that's what happens to the input, and on the other side is the output. I want you to imagine it like a machine where something goes in, something happens to that thing that's gone in, and something completely different comes out the other end. In this example, my input, my first input is 2. 2 enters the machine. The function remains the same each time. The function is always going to be multiplied by 6. Therefore, I need to do 2 times 6, and my output will be 12. If 4 enters the machine, I still must multiply that by 6. 4 times 6 is equal to 24. And finally, if 3 were to enter the machine, 3 times 6 is equal to 18. Whatever number is input, you need to do whatever you're asked to do in the centre in order to get your output. Pause the video now and have a go at solving these questions on your piece of paper. In this function machine, we were adding 6. 2 add 6 is equal to 8, 14 add 6 is equal to 20, and 3 add 6 is equal to 9. Well done if you answered those questions correctly. Sometimes on our function machine, however, we will also have to use the inverse. In this example, I can see my function is to multiply by 3. Something multiplied by 3 was equal to 6. If 6 is my output, in order to work backwards and find the input, I will have to do the inverse. The opposite of multiplying by 3 is dividing by 3. If 6 is my output, I would have to do 6 divided by 3 in order to get 2. Let's quickly now check if that works the correct way round. 2 times 3 is equal to 6. Good. My next question says 14. 14 is input into the machine and it's multiplied by 3. At this point, I will need to do 14 times 3. I don't know my 14 times table, so I'd either need to use short multiplication or a mental method. I know that 10 times 3 is 30, 4 times 3 is 12, add them together to get 42. My final question, you can see I'm going to have to use the inverse again. I know my output is 12. Something times 3 is equal to 12. To do the inverse, I would do 12 divided by 3, which is equal to 4. Pause the video at this point and have a go at solving these questions. Remember, if you know what your input is, you're solving the function as it states. If you know what your output is, you will have to work backwards using the inverse operation. Okay, so the opposite of timesing by 10 is equal to dividing by 10. Something times 10 was equal to 30, so to do the inverse, I would do 30 divided by 10, which is equal to 3. 14 times 10 is 140, and something times 10 was 120. To do the inverse, it would be 120 divided by 10 is equal to 12. Finally, in the last set of questions you might come across, you know what number was input to the machine and you know the output of the machine, but you do not yet know your function. In these examples, you'll have to do similar to finding your sequence and work out whether you're adding, subtracting, multiplying or dividing. In these examples, I can see my numbers are getting bigger, so I'm either adding or multiplying. Let's see if I was adding. 5 add 20 is equal to 25. Let's check that works for the rest of the numbers. 7 add 20 is equal to 27. My output for 7 is 35. That tells me I cannot be adding and I must in fact be multiplying. So I need to decide what have I multiplied 5 by in order to get 25. 5 multiplied by 5 is 25. Does that work for the other functions in this machine? 7 times 5 is equal to 35 and 90 times 5 is equal to 450. So in this example, I'm multiplying by 5. Can you have a go now, pause your video and work out what you are adding, subtracting, multiplying or dividing in these questions? The first thing you should have seen is that your numbers are getting bigger, so you're either adding or multiplying. You then hopefully would have realised that you are not adding because it does not increase by exactly the same amount each time. You were in fact multiplying. 5 multiplied by 7 makes 35, 7 multiplied by 7 makes 49, and 90 multiplied by 7 makes 630. Well done if you got that one correct. That's the end of my input, so what I would like you guys to do is have a go at the worksheet. You can see in front of you that your worksheet has the first 4 questions that we've already seen, and then the function machine questions, At the end, you also have a challenge. That challenge is similar to a function machine, it's just presented in a slightly different way. Have a go at the challenge, but don't worry if you find it confusing. Tomorrow, you will find the answers to all of the questions will be shared with you at the beginning of the lesson. I hope you are able to complete this work, but do remember, if you do find it tricky and you need extra help, just let your teachers know on Seesaw. Good luck!